Hello students, this is lecture number 24, okay, and we are into chapter number 6 plus 7 plus 8, okay. So few things are, we are actually done with chapter 6 and we are now talking about chapter number 7, okay, and it is also connected. So basically problem is defined here. 7 is talking about the kind of test function we can use or types of elements and all, and then 8 is simply the solving the problem. Okay, so in the last video lecture we looked at the 2D heat transfer problem, and we found out, we actually derived this kind of thing, Ku equal to F, where F basically or it was in this form, T equal to F form. So this is for temperature, this is a stiffness, and F was given. And in general we found that K may be given by like something like this. So Bt d p d omega, okay. In general it is like that, in general, okay, where d is basically k11, k12, k21, k22, yeah. So this is conductivity matrix, VT matrix, okay. This is anisotropic, yeah. For isotropic, D becomes nothing but equal to K1001 simply, yeah, where K is K equal to isotropic thermal conductivity. Okay. So if we have isotropic, then D takes this form, and basically we can just write K for isotropic case. Isotropic, we can simply write K equal to infinity B T B d omega, where K, write K inside that. Okay, now where this B matrix is nothing but, we looked at last time, and this was B is 2 by, so 2 by n matrix, so this becomes del n1 del x, del n1 del y, del n2 del x, del n2 del y, and goes till del nn del x, del nn del y, okay. So basically this is 2 by n matrix, where n is the number of nodes in the element. Okay, now in general you can find out K like this. This is in general you can write like that. For isotropic, it's this is the what the form is. Now next remains basically what is the value of these, yeah. So we look at the 4 noded the rectangular element, and we'll try to see what is the form of that. Yeah, so we can see that. So let's say B not B, but for us the rectangular element is like this. So 1 2 3 4, yeah, then we have like this and this. So we have A. So this is at minus A over 2 minus B over 2. This one is A over 2 minus B over 2. Point 3 is at A over 2 B over 2. 4 is minus A over 2 B over 2. Okay. So if that is the case, then n becomes equal to 4, and n1, n2, n3, n4 we have derived in last lecture video, and we can find out, like if you say k11, so we know that k is given by this small k and b t b d omega, where b is given by like that. If you see that, if we b transpose becomes n over 2 n by 2, b transpose b becomes n by n, and this will be how it will be. If you look at b, so we can find out like this, btb, that becomes equal to, so we will have like this, we will have dn1 dx, dn1 dy, and so on, dn n. In this case we have 4 basically, dx dn4 dy, right, and then we have dn1 dx dn1 dy, and so on, dn1 d, sorry, not n1, dn dn 4 dx del n 4 del y. Okay, so see, this multiplies the first, like k11 will be based on this first from here, so this multiplied by this plus this multiplied by this. So del n1 del x square plus del n1 del y square, that's what that will be. So basically what I mean is k11 or kij, simply you can write kij equal to, okay, k multiplied by del ij. So ij means ith row, okay, so ith row and jth column. So let's say we are talking about k41, so we go 4 here and 1 here. So what do we get? K, this multiplied by this, so del n4 dx del n1 dx plus del n4 dy del n4 del y multiplied by del n1 del y. So we can write like that. So this becomes simply, we have the I first, so del ni del x del n, then j del nj del x plus plus del n I del y del nj del y all together del omega. This is how the kij where can be found out, where kij is a part of this. Yeah, so this is will be equal to like this k11, k12, and so sorry, not k. Yeah, basically this is different k though. This is not component of D, so this is not part of D, right? So okay, this is different k1, k2. This is this belongs to the okay, so just to remove confusion, we can also write dash, let's call it dash, 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 dash. Okay. Okay. Okay, so k14, and similarly we have k41 to k44, right, in this case, because there are four nodes, so it will be like that. Okay, so this is how it is given by. Now that given this, we can find out k11 now. So k11 is equal to this, simply k del n1 del x square plus del n1 del y square. And how to find out? We have to find out n1 first, right? So we know n1 we gave as, so we took this line and this line. So this line is x equal to a over 2, so x minus a over 2, right? Just similarly, this is x b equal to b over 2. So simply it was, you can find out, k will be simply like this, equal to 1 minus so we had x minus a by 2 multiplied by y minus b over 2, okay, and then we have over a times b. Yeah. Okay. Fine. Okay. So if you put x equal to minus a over 2, so this will be a minus b over 2 here, this will be b a times b minus a times minus b divided by ab, that becomes equal to 1. So this is correct. So we have n1 like this one, so we know that del n1 del x will be simply equal to 1 over ab y minus b over 2, and similarly we get del n1 del y will be equal to 1 over ab x minus a over 2, and we can use this one, this value here, to find out the value of k11. So we have k11 is equal to k, we can take it as a constant, and then we have a over 1 over ab, 1 over ab, and this. So 1 over ab square, and then x minus, so x minus a over 2 multiplied by y minus b over 2 d omega omega. Okay, so when we say omega, so ab. Okay, so when we say omega, that really means we have to now implement the integration. and we are saying this is our area to which we have to find out the area. This is area integral basically. So basically what it means is we have to apply to the area, and hence you will have double integral, yeah? And double integral of you have x which is moving from minus a over 2 to a over 2, and b you have minus b over 2, yeah, and then we have k over a b square x minus a over 2 y minus b over 2 d omega, yeah. And you can separate it. Now you can assume k to be constant, so k over a b square, and then we have minus b over 2 to b over 2, this is y minus, okay, here it will be not d omega, so simply this will be, okay, you have dx and dy both. So we will have y minus b over 2 dy times minus a over 2 to a over 2 x minus a over 2 dx. So this is how it will look like. Okay, and then we have to this is separated because the x part goes here, y part here, we can integrate it. So simply this becomes k over a square times b square, and then we get this one, this becomes y square over 2 minus, okay, so minus okay. You can also find out like this, you know that, I mean you can just apply the concepts of Gauss quadrature. You know that this is linear, so we can just have like in the middle, so at y equal to 0 value and multiplied by the whole length, so b times minus b over 2, the value will be minus b over 2 minus b square over 2 will be the answer. Or you can also write now without using Gauss quadrature, we can also write, and the value will be, so you can see here, this will be y square over 2 and then b over 2 y, and you have from b over 2 to minus b over 2, okay, and then multiplied by again similar things, x square over 2 minus ax over 2, okay, so and then here also you have a over 2 to minus a over 2, yeah. So what is the value? So value will be, so this will cancel out, this is since this is y squared, so only remains this one, and here also linear, so multiply by b only, so what you get is minus b square over 2 from here. From here similarly you get minus a square over 2, so you get k a square b square k a square b square by, so you get k over 4 simply, so a square times b square multiplied by b square over 2 times a square over 2, so we get simply k over 4, which is the answer. We simply get 4 here, nothing else. Okay. So k11 is simply like this one. Now the other values accordingly we can find out. You know now the value of this one is the x minus a over 2, so we can find out very easily basically. So k11 we found out. Now k12, so we have, surely you can do it, yeah, okay. So k11 we can, if you have found out, same value will be for all. So in fact there is a symmetry, because you can see here these all are symmetric here, right? So if you see here, all of them have like a first of all a rectangle, yeah. So because of that, all of them will have the similar k, and hence you can write that k11 equal to k22 equal to k33 equal to k44, which is equal to k over 4. Either you can use the symmetry to find out the value will be like this one, or you can find out yourself. Okay, so second thing is we are going to find out k12. We don't know what k12 is, but what we know is k12 will be equal to k23 will be equal to k34 will be equal to k41, because all symmetric, right? So if you see from here, no, okay, one thing, this will be equal to this one because the width is different. So this will be equal to this one, and this one will be equal to this one. So here it is symmetric, because if you see this node has this connected to this, like all other three, you can see it is connected in the similar way. So the distance from here to here, for example, is a, here to here b, here to here root a square plus b square. Similarly, you can see the similar kind of situation is from here also. For this also the similar situation. For this also similar situation. So all symmetric. So hence this will hold. Although this and this will be equal, and but we can actually guess, if you know this one, you can guess this. What you have to do, you just interchange a with b, you will get it, right? So all those things, either this is also insight basically you can use to be fast at calculating. So say k12 we want to 1 2 3 4. So k12 equal to we will have basically, so minus b over 2 to b over 2, x minus a over 2 to a over 2, then we have k, okay, and then then we have del n1 del x del n2 del x plus del n1 del y del n2 del y, yeah, and then dx dy, yeah, where n2 will be equal to, so n2, so this is this equation and this equation. So simply we have this equation, no, this is y, this is x equal to minus this. So we have a n2 equal to x plus a over 2 times y minus b over 2, so that when we have x equal to a over 2 and y equal to minus b over 2, so you get minus here, so you get minus 1 over ab. So this is the equation. So del n2 over del x, you get minus 1 over ab, y minus b over 2. Similarly, del n2 del y will be equal to minus 1 over ab, and we get x plus a over 2. Okay, so we can use that. So now we have del n1 so this value we can use directly, and be that. Yeah. So okay, so we have AB y minus b over, so both will be minus only, so we can accordingly use it. So del, and in this case we have minus and like this. Okay, so K12 is equal to, so minus b over 2, so b over 2, a over 2 minus a over 2. Okay, then K del n1 over del x, so del n1 over del x will be equal to 1 over AB. Okay, so the del n1 okay, 1 2, so del n1 over del x multiplied by del n2 over del x, so del n1 over del x will be 1 over AB y minus b over 2, so this is what del n1 over del x multiplied by minus 1 over AB, and then we have, in this case also we will have y minus b over 2. Yeah. Okay, then we have plus, and we have 1 over AB x minus a over 2 multiplied by minus 1 over AB, and we have x plus a over 2. Okay, so dx multiplied by dx and dy. Okay, so will be equal to, now we have this square, okay, and okay, just a minute. Okay, I made a mistake, because if you see here, this has to be a square. Yeah, so what I mean to say is, here del n over del x is square, so del n over del x we have to make it a square basically, and this also need to be a square. Yeah, so we have to be careful. So del n1 del x, so I will use the red pen now. So this square is fine, we need to use this and this as well. Yeah, and hence we will have this and this. Okay, and accordingly we will have this one and this one. Hence the value given here is not correct, so I'm going to strike it out, so we can calculate that later on. Okay, so till here our answer is till here only, so we will calculate this later. Okay, so this I came to know that I made mistake, because if we see here, we have, for calculating K12 we get 2 of them here, right? So what you see is it will be a square here and like this one. Yeah, so that means something was wrong, and hence I get. Okay, so now you can calculate. We have common is minus okay, I think one more thing we have to see. So there was one more probably. So here also you see that it says square plus here. Yeah, so square of this plus square of this. Yeah, so I think this kind of thing we did not do here, so there is another mistake here, and this has to be plus. Yeah, so it will go like this one. Yeah, okay, so basically here plus like this, and hence we will have here like this and plus here, which will like this. Okay, sorry about that. So but this also means that you have to be careful basically. Yeah, so you may make mistake. So here so we have minus 1 over k over a b, a square b square. So we have k 1 over ab minus 1 over ab, so that's what we get in common, and then rest is we will get like this one, and then this one has only this one will have only y path. This one has only y path, so we can write that as like this. Okay, maybe we separate them out first. So minus b over 2, b over 2, a over 2 minus a over 2, and then y minus b over 2 square dy dx plus minus b over 2 minus a over 2, and then we get this x square minus, so x square minus a square over 4 dy dx. Okay, close. Fine. So here we what we see here in this case only y, so we know that only y function you can integrate. This one will be basically we can write it as like this, equal to minus a over 2a over 2 dx. Okay, okay, so we also have something in common, so we have to write first. We have common minus k over a square b square, so minus k over a square b square, and then we have that, so minus a over 2 dx minus b over 2, and then we have y minus b over 2 square, so y minus b over 2 square dy plus minus b over 2 dy, and then minus a over 2 x square minus a square over 4 dx. So we have separated them out, and hence we can now calculate, and what do we get from, so we write minus k over a square times b square. Okay, this value is just a, and what is this value? This one will be, we get y minus b over 2 cube over 3, right? This is from b over 2 to minus b over 2. This value is b, so similarly you can have here b, and here we have x square x cube over 3 minus a square x over 4, right, and then you have a over 2 minus a over 2, okay, equal to, so we have now a here, b here, a square b square, so we will get minus k over ab simply, okay, and then we have something else, so minus k over ab, that will get, then if you put b over 2 here, b over 2 here, we get 0, so that means this value becomes 0, and then we have minus, then we get minus b over 2, we get b, so b cube, so basically the value becomes, we can write it as like this, so 0 minus minus b cube over 3, yeah, and in this case we get okay, so both of them will be just we multiply by 2, so this becomes, because all of this is even function, odd function, so we just multiply by 2 times b times we put value of a over 2, that's it, so we get multiplied by a cube divided by 3 times 8, 2 times 2 4 times 2 8, 8 times 3 24, so 24, okay, and similarly this becomes equal to a cube over 8, a cube over 8 and multiplied by 2, so this is what we get here, yeah, okay, so the final answer becomes k, so the final answer is, so we have minus here, minus minus plus, so becomes b cube over 3, okay, so okay, maybe I write it in red here, so minus, we'll keep minus, so let's put it minus here, minus, then k, minus k over ab, then we have minus plus b cube over 3 over 3 b cube over 3, and then here we get times 3 here, times 3 3, so minus 2 a cube, so minus a cube equal 12, so minus a cube over 6, okay, so minus a cube over 6, so we have, so yeah, here we also have a term here, so I think I did not write that, okay, so oh, this cancels out. Okay, this, so we wrote a times b, this cancels out, so becomes like this one. So b, we should not count it b here, so it's fine now. So we should not write this one. Yeah, so I have already taken a and b into account here, so b will not appear here, so 2 will be there. So we get a over minus a q over 6. Okay, hopefully everything is all right now. So we have bq over so here we have minus plus bq over 3, so bq over 3 is here what we get is we say times 3 here, times 3, so 1 minus 3, so minus 2 over 24, so minus 2 over 24, so minus 1 over 12, and minus 1 over 6 aq, so minus, so this is how. Okay, so done. So that really means that we can write the final value, and now the final value will be k12 equal to, so k a square b square, and minus becomes plus k a square b square over 18. So we can write it as k12 is equal to k a square b square over 18. Okay. Okay, so hopefully this is all right. Okay. Okay. Now similarly we can find out k11. So we made mistake. So let's look at that. Okay. So k11. So k11. So we are till here. So k over ab square. K over ab square, and then y minus b square, and here also like that. So we have some mistake here as well. So if you see here, dx term will also appear here. So dx term has to be there because dx dy are together. Yeah, so there are some problems basically, and because of that, so I'm going to actually strike it out, these two. Yeah, so this is also a problem. Okay, so we will start from here. So k1 k11 has this path, and from there we go ahead. Okay, so k over ab square and that. Okay, so k11 so k11 is minus b over 2 minus a over 2 then we have k over a square b square, then the x term, so we have the y and x, so y minus b over 2 square term, and then we have x minus a over 2 square term, and then we have dx times dy, and which will be equal to, we can separate them out, so minus b over 2 minus a over 2 k over a square b square, then y minus b over 2 square dx dy, and similarly we can have plus minus b2 b over 2 to b over 2 minus a over 2 to a over 2 k over a square times b square x minus a over 2 square dx dy. Fine. Okay, so next we can write this one. So as equal to k over a square times b square, and then we have if you see this, only y is the variable here, so x term can be taken out, so x term will be minus a from here to here multiplied by just dx, so we get just value equal to a only, so we get a, and then we have minus b over 2 to b over 2 and y minus b over 2 square dy. Okay, similarly we get plus k over a square times b square, and then you get b here, and minus a over 2 to a over 2 and x minus a over 2 square, sorry, a over 2 square dx. Okay, so will be equal to k over a square times b square, k over a square b square, and then we have a, or maybe write a b only, a and b only. We have taken out okay, no, we don't do like that. Okay, so let's write a square b square only, then multiplied by a, and then we have y minus b over 2 cube divided by 3 b over 2 minus b over 2 plus k over a square b square multiplied by b, and then we get the same thing here, x minus a over 2 and then cube over 3, and this gives a over 2 to minus a over 2 will be equal to get k over a square times b square and then a over 3, and we know that if you put b over 2 here, it will be 0, so that means you get minus, so 0 minus, and we get minus b cube, simply 3 is taken out already. Okay, so this is done. Similarly, we have plus k over a square b square times b over 3, and similarly here also 0 minus minus a cube. Okay, so the value will be, we have 3 here, a times minus plus, we get minus plus ab, so k over ab, so value becomes equal to k over ab simply. Okay, k over ab, because so we have a here, okay, so rest is, so ab is common now, so minus plus this is b square now over 3, so b square, sorry, so b square plus a square over 3. So we get k over so what do we get? We can write it here. So we get k11 equal to k over ab multiplied by a square plus b square, and 3 times 3 is 9. So k over 9ab a square plus b square. So that's what we get here. Okay, is it okay? So if we see a k12, we are getting something like this one. So if you see the units wise, this is not correct, because what you are seeing is you have a square divided by this. So but in this case we are not getting the similar thing, so we have to check basically what happens. So k12 we have okay, this is because of again the same some mistake we have been doing again and again. So we have this a plus here, so so we need to have a plus here. It's not that these and these are multiplied, and because of that we got wrong answer. So it has to be plus like this. Yeah, so in that case you will have plus here again like this. Okay, and then you will see like a and b cannot be removed that way, so we'll have values intact. So this value is not correct, so let's strike it out like this. Okay, and here we'll have a minus k, let's write a square b square like it is here, and then we have to multiply it by a here, so everything will be a here, and then everything will be in this case b. So this b was actually correct. So so let's write like this. So this a I will write it here, and this b I will write it here. So let's write as a here, and b will be here like this one. Okay, and there has to be a bracket, so put the bracket here so that this is common to all of them. So this becomes like this, hence k12 becomes not equal to this but equal to, so we can simply write here. So basically what we get here, minus k over a square b square. So let's write here minus k over a square b square, and then a b cube minus, so this is minus plus minus plus a b cube over 3 a b cube over 3. Okay, now next 2b, and this becomes a cube over 6. So calculations remains the similar. So a cube over 6 but multiplied by b, so b a cube over 6. b a cube over 6. So b a cube over 6. Okay, then okay, it will be negative sign. Yeah, this is a negative sign, so we had a negative here actually, and we can see here also. So if you multiply 3 here and 3 here, so 23 over 24, so this becomes a minus, so minus sign, so hence we'll get minus sign. So we have minus here. Okay, and so the value becomes minus and minus plus. To begin with, a square b square, so we have ab from here, ab from here, so so we simply get k oh okay, okay, yeah, so again time and again I forget that this is a plus here, so we can multiply like this one. So here we have a minus sign, yeah, so this is a minus sign here. Okay, so let me write like this. So this is a minus sign here like this, and these are separate. Okay, so okay, so what do we get? We get a b cube, so a square b square, let's say get rid of a square b square, so we get k first, k over, and we write ab, k over ab, because we get ab from here and a from here, and then we get the value becomes, and the minus go, so this this is minus here, so we write minus k here over ab, and then ab we are taking out, so b square over 3 minus a square over 6. This is what the value is. Okay, so b square over 3 minus a square over 6. Okay, we can write equal to k over ab and write like a square over 6 minus b square over 3. So this is what the value will be. So now it you can see now at least the units wise it's matching basically. So you can see here ab, here a squared, so that means dimension is similar to, I mean their dimension is cancelling out, so here meter square, this also will be meter square. So if you see for k 2, here also we get the similar kind, right? So like this one. So we can write here that k11 is k11, k12, so k11, so k12 is equal to k over ab, so k12 equal to k over ab, and then a square over 6, a square over 6 minus b square over 3. So this is how it is. Okay, so this is how we find k11, k12, and similarly we can find out. Okay, so the idea is to derive everything in front of you, and we made some mistakes, and hence it's very important that you be careful. Yeah, uh, and especially where you have two dimensions, x and y, so we have to accordingly be careful in while integrating. We have also terms n1 over del n1 over del x multiplied by del n2 over del x plus del n1 over del y multiplied by del n2 over del y. So we have to be careful here. So there is a plus sign there, so terms will be separate, we cannot multiply them together. Yeah, so but ultimately these are doable. So it's a k11, k12 we have found out. Similarly we can find out for other value. So as I said earlier, this will be equal to k22 will be k33 equal to k44, and this will be equal to k12 for sure, k12 equal to k21, so will be equal to k21, will be equal to k. So if you see here like this, so rectangle, so this one is 1 2 3 4, so k12 k21 is equal to k43 k34, so k34 equal to k43 because of symmetry. Okay, now next is what will be the value of this k23, and so you can find out, we can just interchange a and b, you can find out. So k23 or 14, okay, so k14 will be equal to k over ab, and then we have a, instead of a we will have b square over 6 minus a square over 3. Yeah, because a and b you are interchanging, that's it, right? So because of that, so you have between this and this we have n1 n2 based on n1 and n2. Now you have based on n1 and n4, and what is the difference? Difference is the distance between the two, that's it. And hence a and b, if you interchange, you should be able to get it, and this is the what it should be. Now this will be equal to k41 will be equal to k, should be equal to k23 will be equal to k32. So 4 times 4 16, out of 16 we have 4 here, 4 here, and 4 here, only 4 now remaining, and that 4 will be because of this one. What is the value of 13, and the value will be same, k13 equal to k31, k24 equal to k42. So that's what you have to find out next, and you will be done. So next is k13 is equal to what? Because if you know, then you can find out k31 will be the same value, will be equal to k24 will be the same value, k42 will be the same value. Why? Because of symmetry, right? So this is symmetry, this is a rectangle, so hence these to this symmetric to this to this, diagonal, both diagonal, and hence like this. So next we will do is what is the value of k13.